Okay, I think we can get started as people continue to join. Thank you so much for taking the time to join us today. I'm really happy to be talking with you all. My name is Sara Hodges, and I was the Director of Data and Visualization at EdBuilds. Before I start, I just want to mention two housekeeping things. The first being that we are recording this session, and it will be available for viewing. We'll email it out to you when it is and also post it on our website. And then secondly, closed captioning is available for this webinar. So if you'd like to see that, there is a closed captioning link at the bottom of your screen. So I'm just going to start sharing. Actually, no, I'm gonna just have my actual human face for a little bit. So I'll just start with a little bit of information about me. So as I said, my name is Sara Hodges. I studied math and fine arts printing in undergrad, and then went to grad school for geography, which is my true passion, other than education finance. And I started my career in environmental science and did lots of projects like designing wind farms and creating maps about climate change and working with the UN in Afghanistan. And then I decided to switch to studying people and public policy and was very fortunate to land at EdBuilds. And I was with EdBuilds for 5 years, almost the entirety of its existence. So as the Director of Data and Visualizations at EdBuilds, I spent a lot of time with education, finance, and demographics data, as did all of the members of the data team. And in that time, we learned a lot about the data and a lot about the systemic issues with funding education, education funding, sorry. And we created a lot of tools to help us to research and understand. Because we had the opportunity to close intentionally, we were able to take the time to repurpose our tools so that other people could use them as well. So today I'm going to show you all of those tools and hopefully how they can be useful in your research. Okay, so before I begin, I would just like to give a big thanks to Bellwether for hosting this session and for tomorrow's workshop. Especially Lindsay Ferguson, who's done all the organizational heavy lifting, and Alex Spurrier, who will be manning the Q&A. And he'll be introducing himself in just a moment. This is the outline of what we're going to talk about today. First, I'll start with a short overview of EdBuilds data research, just to give some sort of context into why we created all the data sets and tools that we did. Then I will actually go through the education data that we use to create our master data set and have a bit of time for questions after that. That is sort of a large portion, so we'll take a 5-minute break for a little breather right after that. And then the second half of the talk will be about using EdBuilds, the resources that we created. And I have structured it so the first part of that is semi-technical, the tools that people that don't have a lot of data skills can use to analyze and explore our master data set and education funding and demographics at a state and district level. And then I will end with an overview of EdBuilds' more technical resources. That is our two R packages and the resources on GitHub that have scripts for all of the projects that EdBuilds completed. So Alex, do you want to introduce yourself and actually also tell participants what to do if they have a question?
Sure, thanks, Sara. As Sara mentioned, my name is Alex Spurrier. I'm a senior analyst with Bellwether Education Partners. And if you have questions during the course of the presentation, please submit them through the Q&A feature on Zoom. I'll be monitoring them. And if I am able to address any of them, I will try to do so. If not, we'll hold probably most of them for the times where Sara has marked out for Q&A. But if there is something urgent enough, I will jump in and we'll hopefully get those urgent questions addressed if they do rise. So I'll be seeing you all in the Q&A.
Great, thank you, Alex. Okay, EdBuilds. We were an organization that worked to bring common sense and fairness to the way that states fund schools. We all had that sort of memorized and as like our foremost thought in our minds. So the things that we wanted to show or point out is that school funding systems in America are arbitrary. They fail to support students in accordance with their needs. They are inequitable. They often produce higher funding levels in low need affluent districts than in the school system serving students with greater needs. And segregating. They promote division by incentivizing and entrenching segregation along racial and economic lines. So I'm going to do a really quick walkthrough of the arc of EdBuilds data-driven national level research. So I would just want to ground us in the types of questions we were asking and give some context to why we created the data sets and tools that we did. So I'm gonna, well, first I'm gonna hop through this map that you can see right here, which is the very first thing I ever did at EdBuild was to create this, a map of every school district in the country and the student poverty rate, which I was very surprised when I joined EdBuild to learn had never been done before. And so we started exploring the map ourselves and trying to understand the systemic funding issues and really just how they played out on the ground. And one of the first things that I looked at, or we looked at, was Nebraska. We just were looking around for strange looking things, and turns out Nebraska looks very strange. All of these school districts are not the regular squares that you would imagine. And it just made us realize that minor decisions in the past that people didn't even consider the implications on education and education finance can have huge implications for the future. And then we learned that thought about how school district boundaries define both where children go to school, but also define where the money stays. By looking at places like in New Jersey here, Camden, New Jersey, where there are 32 school districts within 5 miles of Camden, all whiter and wealthier and able to raise much more local revenue than Camden is. And then we saw how school district borders can be a powerful way to keep money in and kids out, like the 182 school districts that are completely within another district, similar to Piedmont here, which is completely surrounded by Oakland, whose student poverty rate is 20 percentage points higher, and the percent of students that are non-white is 50 percentage points higher. Piedmont has found ways to get around the property tax cap in California and is able to raise almost $2,500 per student for their kids alone through this back door. And then we learned that school district boundaries are not always stable and immutable when we looked at Birmingham, Alabama, and wondered what the hell is going on here. And learned that 7 communities around Birmingham were allowed to secede from the county school district, even under a desegregation order, and even though it increased segregation. And that a new area, Gardendale, in red right here, was trying to do the same thing. And even further, that there were 127 other places in the country that had attempted to secede from their school district since 2000. So these are all the stories that we started with and explored that are examples of the bad incentives in education funding, the biggest and most pervasive being around local funding. So we started to take a look at what we had learned in that exploration. And there was a tremendous amount of policy research done by the policy team and lots of lessons learned from working directly with states to overhaul their education funding formula. And combining all of that with our data research, we started to explore the data more systematically. So we did this project where we identified all the neighbors for every school district in the country and calculated the difference in student poverty rate. And we found the 50 most economically segregating school district borders in the country, which when we did this project in 2016 was Detroit and Grosse Pointe. This was one of the very district borders in question in Milliken v. Bradley in the early 1970s which said that, to put it very quickly, that other school districts could not be forced to remedy segregation unless segregation was an explicit policy of that very district. The result being that suburban districts around Detroit would not have to participate in desegregation efforts, similar to all over the country. And then 50 years later, it is the most segregating border in the country. And then we calculated the $23 billion wealth transfer from white to non-white school districts, and showed how that plays out at a local level across the country by exploring neighboring school districts with a large racial divide and a large revenue gap, like Allentown and Salisbury here, where there's a 60 percentage point gap in non-white enrollment, and Salisbury receives $10,000 more per student. And then finally, we showed that you really could fix a lot of these inequities by pooling local revenues. Nationally, if we pooled local revenue at the county or state level, 69% of all students would receive equal or greater funding. So I just wanted to quickly share sort of the arc of our data exploration. Number one, because I think it's interesting to be able to look at it in hindsight. And number two, because any data set is a reflection of the people that created it and the purpose that it was created for. And the first step of using a data set effectively is understanding these two things. So in each one of the projects that I just mentioned, we discovered something new about at least one of the data sets that we were using, and created our master data set and improved upon it with every project. So now I'm going to talk a little bit more deeply about that master data set. I'll start with the data sources that we used and how we combine and process them, and then explain some of the reasons for the decisions that we made along the way. So first, of course, is the education finance data set. We use the US Census Annual Survey of School System Finances, which the F33, commonly known. And that is education finance data, including revenues, expenditures, debt, and assets for all elementary and secondary public school systems. For district and enrollment characteristics, we use the Common Core of data from the National Center for Education Statistics, which is the primary entity for collecting and analyzing data related to education. And the Common Core is just the annual national statistical database of information for every public school district, and it is designed to be comparable across states, similar to F33. For economically disadvantaged, we use the US Census Small Area Income and Poverty Estimates, called SAPE. And those are single year estimates of school-age children in poverty for all school districts with geographic boundaries. And then we use the US Census American Community Survey Education Tabulation, which is a collaboration between NCES and the census to create an American Community Survey data files that reflect the condition of school-age children in the United States. And they provide that in separate iterations based on school type and enrollment, which I'll get into a little bit more detail when I talk about processing. And then finally, we get the school district boundaries from the education, demographic, and geographic estimates. That is something that the Census Bureau collects for SAPE to help determine the annual allocation of Title I funding. So they currently publish these shapefiles annually, though that is a recent fact. They, for a long time, did it every other year. So we join all of that data together and do a fair bit of processing along the way that I'll go through. So we start with the finance data set, since EdBuilds was an education finance organization. And we first multiply everything by 1,000 because that's how the data comes, without all those extra zeros. And then we make a couple of changes to reduce year-to-year fluctuations in the data, so that any sort of one-time cost that a school district gets money for doesn't skew their results for that year. So the first, we exclude revenue for capital from state revenues by subtracting capital outlay and debt service programs from state revenue. And then we subtract money generated from the sale of property from local revenues. So both of those just happen, once. And then to ensure that revenues and enrollments match, we subtract payments to charter schools proportionally from state and local revenues. So I'll explain that a little bit more. So in just under 2,000 districts, revenues received by local school districts include pass-through money for charter schools. And these students are not included in the enrollments in F33 for the district. So if you keep them, it artificially inflates the revenues for those local school districts. So we can't fix this perfectly because every state sends money to charter schools and districts differently. So we estimate it by calculating the percent of revenue that comes from state and local sources for each district, and then subtract the charter pass-through dollars from state and local in that proportion. We also make changes to a few states to make their revenues more comparable to other states. So the first is Arkansas. Districts send their local revenue up to the state, which then sends it back in the same amount, and then it gets categorized as state revenue, but actually it is local. So we subtract, it's categorized as census state, NCES local, and we subtract that from state revenues and add just for Arkansas. So Texas has a system called recapture that's great and very complicated. So in a nutshell, property wealthy districts send some of their local revenue to the state, and then it is sent to other lower property wealth districts, and there are a lot more details in there. But in the F33, that money is included in the state revenue for the receiving districts. So we subtract the property wealthy districts' recapture payment from their local revenue only for the state of Texas. So this avoids double counting and also avoids counting local revenue that the district actually doesn't get to keep because they have a high property wealth. And then finally, for the state level changes, in Vermont, Act 46 was passed by the Vermont legislature in 2015. It's a plan to create, they say, a plan to create larger and more efficient school governance structures in order to increase equity. So what that is in actuality is school district mergers and revenue pooling. And there has been a lot of litigation around this, and there are slight changes to it every year since the law was passed. So to be consistent with Act 46 and US Census data, the student enrollment, state revenues, and local revenues have all been aggregated to the supervisory union level. So after making all of those changes, we calculate total revenue as adjusted state revenue plus adjusted local revenue. And then we calculate cost adjusted revenues. We apply the county level cost of living index from the Council for Community and Economic Research to each school district based on their assigned county from the Common Core Dataset. So we do that so that we can compare revenues in Alabama to New York, say. So to research the systemic disadvantages faced by students and communities of color, we created an additional category that we call non-white students. Oh, sorry, I forgot that part. And then we calculate the proportion of non-white students, So NCES provides enrollment by race and ethnicity, breaking it down in these categories here. But we found the non-white students to be, a way to look at systemic racism in education in a simple way. This category is definitely imperfect and puts white children at the center of the research, but the need for a simple approach made us make these calculations. And I hope that it will be part of a conversation about systemic racism that also looks more deeply into enrollments by race and ethnicity categories. So student poverty. So SAPE counts the number of children ages 5 to 17 that are grade relevant to the school district whose family income is less than the poverty threshold. Now, there are a lot of things in there. One of them is that grade relevant. So what they mean by that is there are elementary districts and secondary districts across the country that only educate students that are eligible for elementary school or high school respectively. So what SAFE does is actually just only count the students for an elementary district. The number of students living in poverty are only the students that are eligible to attend that school based on their age. So it is another way to say that it is the children within the district boundaries for whom that district is financially responsible. So, so children are only counted once then. They're not counted for the high school if they're not age eligible for it. Additionally, if a child attends school outside of the district where they live, then they are counted where they live and not in their attending district. So we take that data set and then calculate the proportion of those student age children that are living in poverty. And so for community characteristics, we use the 5-year estimates for grade relevant children. And the variables that we get from there is median household income and median owner occupied property value. And then finally, using the school district shapefiles, we calculate the area of each school district in square miles, and we calculate the number of students per square mile. So I have a couple of key points to note about all of this data. The poverty threshold is the same across the country, but it does not mean the same thing in every place. Poverty is not free and reduced price lunch eligibility. We'll go into a little bit more detail about the differences between them in a few minutes. But just to sort of set the level, greater than 20% student poverty is considered high poverty, and greater than 40% student poverty is considered concentrated poverty. Another thing to keep in mind is that some of these data sets are not counts of students or children, but they are estimations. So data from both SAPE and the American Community Survey are estimates, and these estimates are less accurate for lower population areas. And then finally, so one thing that I discovered coming to education finance research from the environmental science field is that education data kind of sucks. There's a lot of missing data and inconsistencies in what the same data point means in different locations. And it is just full of caveats, both known and unknown. So all of those things are things that you should keep in the back of your mind when you're using our master data set or really any of this data. So that was a pretty exhaustive list of what we did to each data set, but it still deserves a little bit more time. Now I'm going to actually talk about why we made the choices that we did and what the implications of those choices are, so that you can make an informed decision as to which element of this data set or others that you want to use in your work. So every state and many districts put out education finance and demographic data. So why use national data? So the first reason is comparability. These data sets were standardized by the census and NCES in order to be able to compare them across state lines. And that takes a lot of work. And I promise that none of us are going to do better unless we start building from their data sets and understand how we can improve them. And the second is clarity. Different state agencies publish different education-related data sets that often do not match. The reasons are not necessarily sinister. Each one of those agencies is reporting the data for their own purposes and research agendas, and it can be difficult to understand which of the state data sources is the one that you would like to use. So the national data sets are helpful. And finally, it depends on your purpose. So national data is definitely the right choice for a national study. But even for state level studies, national data sets are useful for comparative purposes and yet for any of your state level research. Okay, and next up is why to use revenues and not expenditures. So the first reason is really that we want to focus on the state level decisions. It's using the revenues helps us to focus on the resources that are available to decision makers from the state and not on decisions made by the district, which are drive a lot of the expenditures. And the second reason is consistency, because revenues include fewer large one-time outlays. There were the two that we removed, but expenditures also include a lot of things that only happen 1 year. And finally, comparability. There are laws and regulations in many states about cash balance that can drive spending decisions, and they are different in each state. So the districts are operating under different circumstances in their spending patterns. And the decisions at the state level made for how revenues are allocated are actually the things that we would like to examine more deeply. Okay, now why exclude federal revenues? So number one, because it keeps the focus where we would like it to be, which is on the state. There is no federal constitutional right to education, as I'm sure we all know here. And states are constitutionally required to provide education for every child in their state. So we want to focus on the state decisions and revenues. And then additionally, because federal revenues operate under supplement, not supplant, where federal money is mostly intended to be supplemental, though not all, and required not to replace state revenues. Okay, so the next question we're gonna work through is which student count should you use? And we'll go through a couple of slides on this one because it's a little more complicated. So students are counted in different ways in different states. We're gonna go through membership, attendance, and enrollment. And they are also, within each one, they're counted in slightly different ways in different states. So for membership, that could mean the average number of children enrolled throughout the school year, or over multiple count periods, or the number of children enrolled over a single count period. Oops. But the bottom line on any of these is that these are the students that the district has to be prepared to educate. And for attendance, it is also calculated in slightly different ways in different states. So average number of children in attendance over the school year, over multiple days, or on one day, which is usually around October 1. And then finally, their enrollment is a version of membership that's reported by the F33, and that is the total student enrollment on October 1. So which one should you use? So we strongly recommend enrollment or membership and not attendance, because it counts the students that districts need to be prepared to educate. And attendance tends to undercount students in high poverty, high need districts, and thus overcount how much money is going to each student in those districts. So I'm going to walk through an example that is very finite to just show you exactly what this means. So this is St. Louis County in Missouri, and I just grabbed the high poverty districts and then low poverty districts in that county to use as comparisons. So Missouri uses average daily attendance. So this chart shows their student poverty rate, their enrollment from F33, and their average daily attendance for every district, the ratio between those, and then what the state revenue per student is if you use either average daily attendance or enrollment. And then that final column is the miscount of revenue per student if you use average daily attendance. So I'll just talk through St. Louis City School District, which is the second row here to give this a little more clarity. So under the enrolled students is over 28,000, but average daily attendance is only 21,000. So if you calculate the state revenue per average daily enrollment, it looks like they're getting almost $5,000 a student. But if you do it per enrollment, which is the number of students that they actually have to be prepared to educate, then it is only $3,700 per student, which is a miscount of almost $1,200. And if you just go down the line, you can see that the miscounts are in the blue high poverty districts are, on average, much higher, $700 to $1,200, where in the lower poverty districts, they are much lower, and some of them are even miscounted in the opposite direction. So I just made a quick scatter plot of the entire county to show this in one image, which is just showing as student poverty rate increases, the miscount per student also increases. Yeah, and this isn't necessarily sinister, but it does make the state look like the state is giving more money. If they're using ADA, it makes the state look like they're giving more money to high need districts than they functionally are. So the next sort of question I want to address is which economically disadvantaged student count to use, because once again, there are many different ways to count them, and different states use different measures. So we'll go through student age poverty rate, free and reduced price lunch, direct certification or identified student percentage, and then some state specific definitions. So as we have discussed, student poverty rate is the proportion of grade relevant children aged 5 to 17 whose family income is under the national poverty threshold. But I thought it'd be helpful to actually see what that is in 2018. This is the most recent SAPE data available. So for a family of 3 with 2 kids, that's $20,231. And for a family of 4 with 2 kids, it's $25,000. So not very much money. And FRL is the proportion of students at or below 185% of the poverty threshold, plus additional children who meet other criteria. It's very big. And students in schools and districts that participate in the community eligibility provision option. So just for a little bit of context, for a family of 3 with 2 kids, that is just over $37,000. Unfortunately, the FRL is no longer accurate for many schools and districts because of that CEP participation. Very briefly, the community eligibility provision means that schools and districts with at least 40% of students that are eligible for free lunch can, from the previous year, can do either school-wide or district-wide free lunch, and then FRL is reported at 100%. So that is great for districts and for children, but it is not great for researchers trying to actually quantify what the number or proportion of students that are economically disadvantaged are in the school or district. And because it can be school-wide or district-wide, you can't always tell which districts have some of their schools that are participating in school-wide free lunch. So it's difficult to know which data is not as accurate as it was in the past. And so direct certification or ISP can be very useful. That is essentially the proportion of students that are approved for free meals without an application. So they're identified by programs like SNAP, or if they're considered at risk of hunger because of homelessness or foster care, for example. So this can be a very useful data set, but it's not necessarily comparable across states because they can have different programs that they're eligible for in order to qualify. and it's not necessarily available for every state. And then finally, different states use use their own definitions, which is usually a combination of measures. So in Ohio, for example, it's a student that meets any of the following, that they're either eligible for FRL or direct certification or directly certified, or students whose families are eligible for public assistance via the state system, or through Title I form eligibility. So through all of this, what should you actually use? For national level research, we recommend using the student age poverty rate. It is the most directly comparable and has the least flaws, though it does have them. And for state level research, it really depends on what questions you're trying to answer, whether you're trying to compare across states. So you really, for state level research, the answer might be student age poverty rate, or it might be one of the others, depending on how accurate they are. But you really should, it really matters. And so before choosing one, you should really look into it deeply. And finally, how are pensions handled? So there are two ways that payments are made into state public retirement systems. One is that the school districts make the payments themselves, and the other is that the state makes the payments on behalf of the school district. So F33 includes the pension contributions from the state in the state revenue, or adds it to the state revenue in these 16 states where that happens. So that makes these two categories directly comparable, but it can be a little bit confusing for the states because, well, you'll see in my next example, but a state reports their revenues and then sees in your research that the revenue that you're reporting for a district is different, and they then question why it is. So I just have an example of this after EdBuilds released some report, I don't remember which one. Illinois sort of contacted us and said that their state report card showed very different revenues than we were reporting in our report. And so we plotted them, and sure enough, they, so this shows right here, the x-axis is state revenues per pupil using F33, and the y-axis is state revenues per pupil using the Illinois state report card. And if they matched, they would just follow the 45-degree diagonal, and they clearly do not. But then we subtracted the pension payments that are included or estimated in F33, and sure enough, then they matched perfectly. So we did not then just remove those payments from our data set so that it would match Illinois, because we want to compare the revenues with states outside of Illinois. So we were able to show the state that our data set was correct and just showing something slightly different, and they then were happy, and we could go back to using our data set that included the pension payments. I'm going to take a little sip of water now. So those are some of the main questions that have come up regarding education finance data as we have worked for the last 5 years. But I do want to add one more level of complexity because there are so many different types of school districts and different things going on that it's important to know a little bit about the outliers and some of the differences that can make a huge difference in your analysis. So through the course of EdBuilds research, we actually created 4 different master data sets that were appropriate for different types of projects. So we called these our standard exclusions. And so that were the districts that have geography with geographic boundaries, general, finance, and all. I'm going to go through each of these. So for projects about borders or things where we're going to be mapping, or projects about local revenue, usually we would use as our data set all districts that actually have physical school district boundaries. And then our general exclusion was for projects about enrollments and demographics, and that they exclude districts that are categorized as vocational, special education, non-operating and educational service agencies. This excludes charters also. Also excludes districts with missing or zero enrollments and those that are from the US territories. Our finance exclusion that we use for projects about education funding excludes all of the same things in the general exclusion, but then additionally excludes districts that have missing or zero operational schools, missing revenues, and very low or high revenues. For the most part, just because we thought there must be something wrong with the data if they're getting less than $500 per year per student. And then finally, we have the all exclusion, which doesn't exclude anything. And you only use that to find specific districts and to explore, but we never wanted to use that for looking at systemic differences in how school districts are funded, because there are so many different special education and regional districts that really just shouldn't be held to the same bar as a traditional public school. So just for a little context, these are each of those exclusions. So for all districts, there's just over 18,000 districts, and each of the other three have somewhere in the range of 13,000 districts. And if you just look at the average poverty rate, local revenue, and total revenue, they don't make a huge difference, but they really can. It still does really matter which one of these you choose, depending on what project that you want to use it for. And finally, a quick discussion about geography. So there are unified school districts that serve all K-12 students. Then there are elementary only and secondary only districts that serve some grade levels. So if there's an area that has an elementary district, then they overlap with either a secondary district, or in some cases, they just send their high school students to a neighboring district. But I just wanted to show where all of these districts are. So these are all of the unified school districts. So of the roughly 13,000 districts with geography, there are almost 11,000 unified districts. 27 states have elementary and secondary districts in addition to unified, and there are almost 2,000 elementary districts and about 500 secondary districts. And I just wanted to zoom in, this is a little blurry, but to show that secondary districts usually cover several elementary districts. So in this little map, the thick lines are the secondary districts and the thin lines are elementary districts. So you can see that there are a number of elementary districts within each of those secondary districts. So that was a whole lot of information about education finance data that we have compiled and turned into our master data set that we'll explore in the second half of this webinar. But I just wanted to pause and check in and see if there are any questions.
So there was one question I addressed earlier, Sarah, on where some of the maps might be available that you were showing at the beginning of the presentation to explore. And I linked to the fault lines section of the EdBuild website. Were there any other areas that folks could find on the EdBuild website where you've got some of the school boundary maps available for folks to explore?
Yes, absolutely. And I am going to be sharing those in the second half of, or the beginning part of the second half of this webinar. So I think I can answer that more thoroughly then.
Great. Well, that looks like all we've had in the Q&A. Oh, we just had another one. Which years are covered in these data sets?
So the master data set is available going back to the 2013-14 school year. And then every school year until 2017-18. Which is the most recent year that has F33 data. So a lot of the data comes out in December, like the Common Core data set comes out in December, roughly December of every year. But the F33 finance data doesn't come out until usually May of the following year. So we wait to make any master data set until all of the data that we compile into it are of the same year. So yeah, so 2017-18 is the most recent that the master data sets are available.
Great. We just got 2 more questions in, one on race and ethnicity, asking if there are ways to get Black data in addition to white and non-white.
Here we go. So American Indian, Alaska Native, Asian or Asian Pacific Islander, Hispanic, Black, White, Hawaiian Native, Pacific Islander, and 2 or more races. So I absolutely do think that using these individually is a very important component of research, and especially looking at systemic racism. Since EdBuild was trying to do a very broad survey of systemic racism, then we created this non-white enrollment. But yeah, one other thing to note about these, like Hispanic, for instance, does not depend on other racial categories. So you can't add up each one of these and come up with total enrollment, which is why we do it total enrollment minus white to calculate non-white.
Great. And then we've got a really very on-brand question for EdBuild. If calculating funding based on membership is more equitable, why did some states make the choice of distributing funding based on ADA?
Ooh, thank you. So, I mean, there are a lot of different reasons that states might want to do that, or different parts of states might want to look at revenues that way. The most common reason given is that that is the number of students that you can assume will be in the classroom that day. So if you can just be prepared for that many students every day, you're probably going to be okay. I say no to that because lots of students might show up one day and you really have to be prepared to educate everyone that is enrolled in your district on any given day. So that, in combination with the fact that it tends to overinflate how much money is given to high need districts, really points to using membership or enrollment to me.
Great. Well, I think that about does it for the questions that we had in the Q&A at this point.
Okay, great. So then I think that it is time for us to take a 5-minute break. I'm just going to put this back into present mode. So it is 1:50 right now. So I recommend everyone just stay logged on, and we just take a 5-minute break in order to refill our water glasses, like me, use the restroom or whatever, and we will resume at 1:55. I was reading through the questions, and I just wanted to clarify a little bit about the question about Black data and whether you could calculate non-Black, which you absolutely could, just doing enrollment minus Black enrollment to get non-Black enrollment.
And Sarah, before we start back up, we've got 2 questions I think might be able to answer, at least one quickly. Is there a list that you have of all the research questions that you have answered using these data sets in your research at EdBuild?
Is there a list? This is the sort of most comprehensive list of things that have specifically come up that we have then sort of changed or understood more about our approach from. There is a list in some of the resources that I'm going to share about exactly how we do each one of those things that might answer that as well.
Great, thank you. And then the second question is a follow-up on our ADA versus membership question. And the questioner was asking how advocates might advocate for moving from ADA to membership. I was wondering if you had any thoughts on that in your work at EdBuild.
Yeah, I mean, what I would do is, because I think a picture is worth 1,000 words, is actually just create those, something that is just like the Missouri, St. Louis County and St. Louis City, whomever pointed that out, is correct. Just making a scatter plot like that to be able to show legislators how it is actually inflating the numbers. They might be interested in that continuing, but I think it's just helpful to point it out and be able to explain how this is actually hurting kids. That could be a really compelling argument that advocates could make to their legislators.
Great, thank you.
All right, thanks, Alex. Okay, so now I'm going to go through the semi-technical resources that EdBuild created to share our master data set and explore the data without actually having to open it in statistical or mapping software. And there are 3 resources that I'll go through. There's data.edbuild.org, Dividing Lines, and our school finance data dashboard. The first one, data.edbuild.org, is very simple. You can download all the master data files and the shape files and read our methodology. And the address is data.edbuild.org. So here, this is what I was thinking. If you want to just see a more succinct description of what our methodology is, this is the best place to find it. And then you can also select a master data file to download, selecting your exclusion, or you can download the shape files. In the past, we did some geographic processing of the shape files, but the census has gotten a lot better and a lot faster in updating the boundaries when, like, say, a community secedes. So at this point, these are just the shape files that we are getting directly from Edge, though in the past it was slightly different. The next resource that I want to share with you is Dividing Lines. And that is an interactive map of every school district with geographic boundaries. And I'll just go to it. So when you load it, it's colored by student age, poverty rate. And you get this information about it where you can click for a tutorial on how to use this. If you just click anywhere, then it opens to just every school district with poverty rate showing elementary and unified districts. You can toggle this and it will load secondary districts. At this scale, it doesn't really look any different. I prefer elementary just because it's smaller scale. This has data going back to 2013. So you can sort of toggle between the years in order to get to see how things have changed. I did that a lot after the Great Recession. So yeah, this was the one that I was thinking would answer that question most specifically. I'm just going to walk through a couple of things that you can do with this, because this is the tool that I literally used every day at EdBuild. I mean, many times a day. When I would do the tracking of who was using our products, I found I was using this one all the time. So you can toggle between student poverty rate or cost adjusted revenue per pupil, percent non-white, median property value, median household income, and also free and reduced lunch. Now, as I mentioned before, FRL is not a particularly accurate variable anymore, but it is still useful since it is used in so many calculations. And you can also then see through the years that some states have just completely stopped reporting it at all, like Tennessee and Massachusetts. So I am going to just zoom around and just show a couple of things that examples of how I find it useful. So you can just type in a school district name and it auto completes, and you can select the school district and it will zoom to it. So I'm just picking on St. Louis today for some reason. So this is St. Louis City School District. And this is showing the proportion of non-white students. So in the tooltip here, you can see that there's 87% of the students are non-white. Another thing that I like in this tooltip is the proportion of revenue from state sources. That's the italicized. And I think that is a really useful indicator just to understand exactly where their money is coming from. And once again, I just want to mention that all of the revenues in here are cost adjusted. But then you can toggle to say, median property value, and just see how these different variables interact with each other by toggling back and forth. I think that is a really interesting thing to do. And another thing, if you go to a place like Birmingham, Alabama, that I was talking about before, that just has a really complicated set of borders that I couldn't really understand when looking at it just as a static map, then dividing lines is very useful because it highlights the border, the district when you hover over it. So this is Jefferson County School District. This is the one that so many districts, so many communities have seceded from. And there are just so many tiny little districts here, like Fairfield and Midfield, that there's no way that you can sort of get a handle on all of these without being able to hover and see them. And then you can also just change the variable to get some different variation in the colors to try and understand that a little bit more. So in general, dividing lines is a great tool to visually explore a school district and see how it's situated. As I mentioned, I used it constantly when I was at EdBuild, and I still use it constantly. You can also see, you have to spell things right in order to zoom to them. You can see the elementary and secondary districts pretty well in here. So if you just keep your eye on this area, you can see the secondary districts are much larger. Yeah, so this is one of my favorite tools that's very simple and you're not doing any analysis, but it just comes in handy. Anytime anyone mentions a school district, you can look it up and just understand the visually how things are situated in the state. So the next one that I want to talk about is the school finance data dashboard. And I'll spend a lot more time on this one because it is actually a way that you can do analysis and download things. It is like an in-depth dashboard to explore school districts in a more robust and detailed way. So I will just open that and refresh it to make sure that it's happy. And this was made by Cecilia Detman, who is a data analyst, senior data analyst at EdBuilds. And she did a lot of work to get this working so well. So first thing that you see is this information that tells you that this is, we are using the geography exclusion for this data product. So that means that all of the information here is about school districts that have geographic boundaries, which is a really important thing to remember as we are looking at it. And then there is a link to the data and methods page. And I'm just going to shut that and start exploring. We have it set so that the first thing that you see is that at the national level, where each one of these dots is a state, the student age poverty against total revenue per pupil. So we start here to sort of set the stage that we should always be looking at data through an equity lens. But it is not a huge surprise that higher poverty states have lower average revenues because they probably have less money. And also this is not cost adjusted, but at the national level, you can just click this button and then revenues are then cost adjusted. So I just want to give sort of an overview of what you can do using this tool, all of the things that it provides. So the first is the national summary stats. So no matter what you select in the geography here between national or the largest 100 districts or any state.
While we're waiting for that to catch up, there's a couple of questions in the chat that I think we might be able to discuss. We had one anonymous attendee say that the 13-18 data is really useful, and they were wondering if anyone's taken on EdBuilds' mission and would provide 19 and 20 data that is similar to what you all have from 13 to 18.
Yeah, I strongly believe that because we wrote scripts for processing all of these, and this is sort of the second half of this hour. We're going through the R packages that we created and some of the R scripts that we created to share with people. And so we actually wrote scripts to process all of this data that makes it a lot easier to create our master data set. So I cannot guarantee it, but I feel strongly that one of the ex-ed builders or someone that then one of us currently works with will be updating to include the 1920 data sets.
Great. And then a Texas-specific question. They have a system in Texas called the Robin Hood system, where property-rich districts pay to the state, and then those funds are reallocated. Yep. Faith was wondering if there's a way to tell using this tool whether or not a district's funds are coming from that source or not.
Yeah, we do. That is a good question. You could tell that from the raw F33, but not in any of these tools, because that's the recapture program that I was talking about in the Texas specific processing. So that is, just going to close that. Yeah, I would recommend just looking at, off the top of my head, I can't remember what the name of that variable is, but if you look in Texas, I think it's L12, that you can see which districts actually are sending money from their local revenue into the state. But yeah, you would have to actually download the raw F33 because we do not include that. If you are using our packages, you can download the raw F33 and get to it, but just as like a standard non-statistical package user, you'd have to just download F33 yourself.
And we do have one other attendee mentioning that when they try to go to the dashboard, they're getting disconnected from the server. As it may not be your computer, Sarah.
Okay, let's try that again. I knew, you never want to do things live. Okay. And so this is the only part of this talk that actually is using live, and there's just no other way to do it. So this has been my one fear, is that this would be bad, but it looks like it is coming back to us. So let's just see if that's true. And it is. Yay. Okay, great. So then let's get back to it. This is made using R Shiny, which is sort of a way to use R in a web browser and make these very complicated data-driven visuals. But we have included so many things in here that it's a fairly complicated script. So as you can see here in the summary statistics right now, I have selected the largest 100 districts. And so this is giving me the total enrollment in those 100 districts, their education revenues, poverty rate, average poverty rate, all of these variables just for those. And when I change it to Alabama, then it changes to the Alabama summary statistics. And I just want everyone, when they're looking at these and everything in here, to remember that this is only school districts with geography. So you'll see that the total enrollment is 48 million. And I think last I heard or remember 72 million that are enrolled in public schools. So this is definitely not everyone, but this is a very good way to understand what is happening in the traditional public schools that have geography. So after that caveat, I just want to show you the rest of these. So revenue sourcing, this is has only one purpose, and that is to show you the percent of total revenues by state and local revenue for each state. So you can just see how different it is. Hawaii is unique because it's only one district that they local stuff. But Vermont, only 15% of its revenues are local, ranging to New Hampshire, its neighbor, where 69% of its revenues are local. And we're actually going to look at that a little bit in the scatter plot as well, in our example later. So, but in the scatter plot, once you have selected it, then in the sidebar here, there are you can expand and contract all of the changes that you can make to this table. So I'm just going to change it to Alabama. And you can select districts to show. So once you select in here, then it actually gives you a list of all the school districts. And so let's say I want to show Birmingham and Montgomery and Baldwin. So then that just shows those 3 school districts in the plot and in the table. That can just be useful sometimes when you're trying to find where things are. You can also change the X and Y axes. So right now, the X axis is the student age poverty rate, but say we wanted it to be English language learners. And then you can select any of these variables to go in the Y axis as well. So yeah, you can change it to local revenue. You can also specify a data range. I'm going to go to Idaho to show how this works. So say that you're looking in Idaho at student poverty rate and total revenue per pupil. But you have this one little dot up here that you'd like to get rid of, just so that you can see exactly what's happening. And because they only have 3 enrolled students. So it's probably a bit of an outlier in Idaho. So I'm actually going to do that. So you could just take total revenue is greater than 50,000 and get rid of it. But I actually, because I'm sort of interested in this, I'm going to look at pupils per square mile. And so when you enter that, you can see that in Idaho, all the school districts range from no students per square mile to 285. So I'm just going to see what it looks like if you change that to 1. And sure enough, it removes that one district that has had only 3 students. And it says up here that 27 school districts were removed from the plot. But then that really zooms in and you can see a lot more clearly what is happening in the data. And you can use this to say, well, I'd like to see what's happening in dense districts in Idaho versus non-dense. Or for instance, if then you wanted to look at the district map. That it always loads with student poverty. But since we were just looking at students per square mile, I actually would like to see where those, where students with less than 1, districts with less than 1 student per square mile are. And as you can see, Bruno Grandview has 0.05 students per square mile. That is extremely rural. And there are a lot of these districts like that. And you can see really that the area where there are more students is just this, I forget which highway this is, I think it's 90. And then the area up here in Idaho. So just from looking at the scatter plot and the map of this with this simple data, you've learned a lot about how school districts are situated in Idaho. And then the last element of this dashboard is the table, which just basically reflects whatever it is that you're selecting in others, but you can, I'm just going to remove, as you can see, it still has that range. I just want to get rid of that so that I remember that it's still there, which I will do by selecting no data range. So that puts all of the school districts in Idaho back. And you can then select additional columns to add to your table so that you can understand more things. And you can additionally filter out things in your table. So we're going to look at all of the districts in Arkansas. So we have right here student age poverty by total revenue per pupil. I'm going to look at local revenue just because I want to. And then I'd like to look at Pulaski County is where Little Rock School District is. And so I just want to see where those school districts are in this scatter plot. So I just searched here for Pulaski to get all the districts in Pulaski County. And if you highlight them in the table, then they get highlighted in the map. And you can see that all of these districts are sort of all over the map, both in student age poverty and in the local revenue that they're able to raise. So in order to unhighlight them, you have to de-highlight there. So I just want to go through an example of walking through a question and showing all of the results that you can, the things that you can do to answer that question. The question that I'm going to walk us through is actually looking at states and school districts that rely heavily on state revenues. So this is important to me because local revenue comes, in most states, local revenue comes from property taxes, at least in part. And this is a huge issue, but property taxes is actually a very stable source of revenue, much more stable than sales tax and income tax. And in like times that we're living in right now, sales tax and income tax is for next year is going to, we predict will be much lower. So states are going to be looking at huge budget cuts. So actually heavy reliance on state revenue in a year like this means that you're going to be more vulnerable to budget cuts. So let's just look at the national level. I'm going to keep it at student age poverty rate and look here at percent of state revenue. So you can see that there is a huge range, as we were able to see in the revenue sourcings before. But really, I would like to look at this at the state level, within a particular state, to show you how that can help you. So I'm just going to look at Ohio. And once again, this is for the 2017-18 school year. You can go back, but that is the most recent year that this data is available. So we have percent state revenue and student age poverty rate. So we can see which districts in Ohio are most reliant on state revenue. And that is just, as you can see from this scatter plot, as the student age poverty rate goes up, so does the reliance on state revenue. That is a great thing in the current system. You would like to be giving more state revenue to high need districts. But in this case, during COVID-related budget cuts, that means that those districts are also just more vulnerable. So I don't actually know what Ohio's plan is for any budget cuts. So I don't want anyone to think I selected Ohio particularly for any reason other than I'm slightly familiar with its funding formula. But you could use a chart like this to advocate for more equitable cuts. And so you can take this scatter plot and just say download SVG. And then you have downloaded this picture that looks pretty good. You know, it's not beautiful, but you just made it with zero effort on your part. Make that go, you can just click it. And then you can also look at this table here. And say, I want to sort it by percent state revenue to see that Western Local School District is the district that has the most state revenue. So right now, these are all of the variables that are shown in here. And I just want to add a few that might be helpful to me. So you can see the local, state, and total revenues, the number of students enrolled, percent non-white. And I'm going to add the state ID because I always want to be able to join my data to some other data source. So now I've created this table and I can actually just download it right here. And if I open it, I'm gonna stop sharing that and just show you this table that I was able to download. So this is what just came sort of straight from this resource, and I am going to just make it a little bit prettier so that we can see it better. I can't stand to see all of these. So with very little effort, we have downloaded a table of all of the school districts in Ohio with the data columns that we wanted. So if you were, for instance, interested in showing the legislator which are the districts that are most reliant on state revenue, then you have downloaded it. You can sort by percent state revenue and highlight the districts that have at least 70% of their revenue coming from the state, and voila, a compelling case for a legislator to look more closely at these districts. I'm just going to go back. Yeah, or once again, you can look at this as a map. We're still on pupils per square mile, but I'll just change this to percent state revenue. So you can see that districts that have a larger reliance on state revenue are shown in dark green. So you can see that it's a lot of this southern Ohio area, but that it's all over the state. So this is just one really small and sort of simple example of a quick analysis that you can do with the data dashboard. But there are sort of countless other things that you could do with it. So those are the three sort of semi-technical resources that I wanted to share with you, and we have a little bit of time for questions.
So we've got 3 questions in the chat, 2 dashboard related and 1 more global. So I'll start with the dashboard ones.
Great.
Do the access options change per state? Just because we know that, for example, Tennessee and Massachusetts don't collect FRL data anymore. Do those options still show up as an access option, or do they drop for certain states where those variables are reliable?
Yeah, the access options are the same for every state, but FRL for Tennessee would just be NA, so there would be nothing on the scatter plot. The thing that does change is the range of the axes, which change to reflect the data. So.
Great. And the other question related to the dashboard is there a way to see the data sources that went into the calculation of each state's revenue sources?
So once again, that would be, you would have to look at the raw F33 for that. And it is very thorough and sometimes hard to parse. But yeah, it breaks down the state and local revenues into probably 40 different variables that you can look at.
Great. And then the more global question, did ESSA's per pupil expenditure reporting requirement help make EdBuilds work easier or allow you guys to do deeper analyses, or the folks that will take up the mantle of EdBuild?
Yeah, you know, I don't know if I can answer that. It's funny because I was new to education research when I started in EdBuild, so I have been living in this world, so I actually can.
All right. Well, that was the total of the questions that we have in the Q&A.
Okay, great. So the next step is for us to go into the EdBuilds R resources. And I think this will be walking through our 2 R packages and the R scripts that we have posted on GitHub so that researchers can recreate any project that EdBuild created. So this is going to be a little bit more technical than the others. I think that people that are not R users could still get a lot out of it and perhaps get inspired to use R. But I just want to give a warning for anyone that doesn't know how to use R that we're going to be looking at scripts and code and things like that. So these are the two packages that are created. EdBuild R, which is for data analysis and exporting tables, and EdBuild Map R, which is for spatial analysis and exporting maps, both formatted and nice and ready to go. And I'm going to be talking us through this workshop on EdBuild R and EdBuild Map R that anyone can look at. So I'll be sharing all of my slides here, so you can just click on here to get to this workshop that we're going to go through. But in addition, I just wanted to link to the CRAN, which is the organization. It's complicated, but that helps with R and helps with our packages. And so you can find out all the information and all of the functions that are included in these R packages by clicking on either of these links. But for ease, I'm just going to switch over here to the section about using EdBuild R. This is Map R. So using EdBuild R, there are a number of functions that are included in EdBuild R for importing data. So a lot of the questions that were coming up in the earlier sections were about specific variables that you might want to access in F33. So if you're using EdBuild R, you can directly import into your into R either the master data sets that I have talked about for the years 2013 through 2018, or F33 that we have processed, that we've just made it look a little bit prettier and done all of the processing that we discussed, or you can just pull F33 raw straight. We additionally have a master code book that you can pull in that lists all of the variables and what their data sources are, which is very helpful when you're actually working in there. And then finally, there is the long master pull, which brings in all of our master data sets from 2013 to 18 in one data frame so that you can do longitudinal research going back to 2013. When you are importing using that master pull function, you can decide which of EdBuild's standard data exclusions you would like to use. So a lot of the tables and visuals that I used in this presentation were actually made using EdBuild R. So for instance, this is the table of each of the exclusions. So all I did for each one of those exclusions is use master pull, the data year, as this one was 2017, now 2018 is the most recent, and then select what the data type is that you would like. And then I use dplyr to do a bunch of things that we don't need to go into. So yeah, so that is the most basic function that EdBuild R does, is being able to import these master data sets directly into your R environment with very little work on your part. There are, just to go back to all of these functions, then we have one analysis function, NADIF, that I'll go through, and then a way to export formatted tables. So NADIF performs a neighbor analysis. So this function allows you to find the difference between each pair of school district neighbors in the country and calculate a national rank for whatever variable that you would like. So the example that I have here is calling NADIF, which is the function, and saying I'd like it to be for the 2017 year, and that I cannot remember what are all of the variables that you can use to do the national rank. And so I just said diff var equals options, and that returns a list of all of the variables that you can actually use this function with. And so I am going to use the percentage point difference in percent non-white enrollment, which is right here. So then now I'm actually doing it for real, so I'm giving it a name. So I'm going to call it NABES. So I'm asking it, R to return a table of every school district neighbor pair in the country ranked in their percentage point difference in percent non-white enrollment. And then I selected type equals like. And so that is just about elementary and secondary districts. So when you say type equals like, that means I only want elementary districts to be paired with other elementary districts, and unified districts to only be paired with other unified districts, which you often would want to choose because elementary and secondary districts are not particularly comparable or have different financial drivers perhaps. So what this function returns, I just took the first 6 columns, is literally a list of every school district pair, which has a unique ID, and their rank of percentage point difference in percent non-white enrollment. Now, when I looked through this, I noticed that the enrollments of these were awfully low. And so I decided that I actually was more interested in districts that had at least 1,000 students so that I could just look at districts that I might have heard of and wouldn't have low enrollments that are messing with the proportion of non-white students. So I just took that NABES data frame and filtered out, so it's only districts that have at least 1,000 students, and then selected some variables. And I sliced it so that we could have this nice table that just shows the top 10 school districts with the highest percent non-white difference, neighbors. And since we filtered out less than 1,000, the highest is actually the 7th highest percent difference in percent non-white enrollment, which is Birmingham City School District and Mountain Brook, which has a 95 percentage point difference in non-white enrollment, which is crazy. And then looking through here, I see a lot of districts I recognize, but I also noticed that there is Birmingham comes up more than once. So I'm going to use that as my example for the next function that you can use in EdBuilds, which is to export a table of a school district and all of its neighbors. So the function is sdneighbor_xlsx, and you just input the NCES ID for the school district and the names of all of the variables that you would like to include in the table. So once again here, I couldn't remember what they were. So I just said options so that it would give me a list of all of the variables that were available. So then I selected name, enrollment, poverty rate, percent non-white, median household income, total revenue, and local revenue. And when it runs, it gives you instructions of how it is to save your table. And then it exports this formatted table of a school district and all of its neighbors to Excel. That looks very moderately nice. So that is all of the functionality that's included in EdBuilds. The part of it that I use obviously the most is just pulling in the master data set and then joining it to other data sources that I would like, or just using it for my analysis in general. Since we created these master data sets, and these functions, it made analysis at EdBuilds so much faster and so much easier, and so much easier to be sure that it was replicable and was showing the same thing as our previous projects. So I cannot underemphasize how much this helped our workflow. So now I'm going to show you about EdBuild Mapper, which is the spatial version of spatial R package. So likewise, it has some importing data analysis and formatted maps functions. This is actually missing one. So you can pull in the school district shapefile, but you can also pull in the state shapefile so that you can use that to actually make some nice looking maps. So in order to import the 2018 school district shapefile, or in this case, 2017, in R, all you have to do is after loading the library, is select your data year, and then whether you want the data, the master data, to be attached to the shape or not. And then it reads it in. Very simple. And this is all using the SF package in R as a base. So the great thing about that is that this is simply a data frame similar to any other data frame in R, except that the last column is the geography column saying exactly where the shape is. So you can see here, I said yes to bringing in the master data. So it looks exactly like the master data set and has all of those variables, except for this final geometry column. So once you have imported that into R, you actually can use just base R to map it if you want. Like for instance, here I just selected Connecticut and a few of the variables and just said plot, and then R just spits out these maps of each of those variables without you really doing anything. The problem is it doesn't actually tell you what any of it means. So you can get a lot more complicated with just base R and mapping, but we also have made functions for creating beautiful maps using the master data set. So in order to create, for instance, a map of the student poverty rate in Connecticut, all that you have to do is use the SD map function, select the state as Connecticut, and the map variable is student poverty rate. And then that exports this quite nice looking map. And when you run that function, then it has a note telling you exactly what to write if you want to save it to your desktop. If you don't, you can keep trying and keep making maps until you decide that you like it. As another example, you can map Connecticut's local revenue per pupil. So once again, use the function SDMap, select the state of Connecticut. The map variable is local revenue, and legend equals true. So if you decide that you don't like this legend and you'd like to make your own, you can say legend equals false, and that won't be included, which can make life easier sometimes. So so the most commonly used around EdBuild and easiest to use for the EdBuild mapper were these two of actually just importing the shapefile and being able to play with it and add it to your data and making simple maps. We do have another function that goes along with the SD neighbor table, which is SD neighbor map, where you just input the NCES ID of the school district and the variable that you'd like to show, and it then outputs a map of that school district and all of its neighbors styled by the variable that you selected. So that, once again, is our favorite Birmingham City School District in Alabama. So I just included the table here so you could see that this could be a final deliverable if you wanted to be talking about a particular district and all of its neighbors. The last thing that I want to show you in EdBuild Mapper is the borders function, which is a lot more complicated than the others. And that is if you get 2019 data and we have not yet made updated this, then you could actually make your own borders data set and use this for a school district or any other type of polygon data to create a data set that is all of the borders of the polygons. And I have to warn you, so you would run it by just selecting the shapefile that you want, what the ID should be based on, and what the variable you would like the ranking to be based on. And then whether you want to export it as a table or a shape. But I do want to warn you that this will take, at least for the school district shapefile for the United States, it takes 15 minutes to run, which is both fast and slow considering what you're doing. So the final thing I want to show you is just a vignette of an actual map that I wanted to create, and starting from start to finish using EdBuild Mapper and EdBuild R. So this is just creating a map of the 100 most segregating borders by non-white enrollment. So we actually created this table back when we were looking at EdBuild R, and it was called NABES. I am just joining that to the shapefile and filtering to get the top 100. And then importing, when I made this, actually, we hadn't yet put in the state shape poll. So now I would actually just import the state shapefile and then use tmap, which is my favorite static mapping package in R, to add the states and add the top 100 most segregating neighbors by proportion of non-white students, and style it a bit. And that outputs this map of the United States with, in red, all of the most segregating school district borders in the country. So that is sort of an overview of what you can do with EdBuild R and EdBuild Map R. There are, if you look at these crayon sites, then you can get all of the help and vignettes and an overview of each one of them in their entirety. And then the last thing that I wanted to show you are the GitHub repos that we have created of every project that EdBuild, most of the projects that EdBuild did in its lifetime. So this is just at github.com/EdBuild, and this is all public. And we have uploaded the scripts for each one of these projects. So 23 billion, Clean Slate, Dismissed, Fault Lines, and Islands, which was the project where we captured all of the school districts that have only one neighbor that it completely surrounds it. And so you can actually look at any of these. I'll just open Clean Slate. And these are the actual scripts that we use to create the project. And as you can see, we always use EdBuild Mapper and EdBuild R. And you can download these or fork them and recreate every one of these projects and improve upon them or change them slightly. So the world is your oyster as far as all of these projects go. So when someone was asking earlier if someone will recreate one of these, one of the things that EdBuild used to put out, at least for all these projects with these scripts and some knowledge of R, then anyone could recreate any of these projects. So once again, these are, are listed here. So the R scripts, and then this is also the repo for the EdBuild R and EdBuild Map R, R packages as well. So yeah, that is all of our more technical resources. So now we have a little bit of time left for questions.
So we just have one question in the Q&A right now, and that's just a clarifying question on charter schools and whether or not they show up at all in the packages that you just went through describing.
So they show up depending on which exclusion that you use. Both the finance and general exclude charter districts. The all exclusion, so if you use master poll and pull in all districts, that does include charter schools. And then the only other exception, there are just in the geography exclusion, there are somewhere between 1 and 10 charter districts that actually have boundaries, and those are included also. But because the local revenue is so different for charter schools across different states, we don't include them in our general finance exclusions.
Great. Well, that's all the questions that we had in the Q&A right now.
Great. Yeah, I sort of thought that the very technical R package section would have the fewest questions because it is the most complicated. But it transformed the way that EdBuild worked, and we were able to accomplish so many more projects and get so much more done. So I recommend, even if you were completely intimidated by everything that I said, just opening R and just using that masterful function to pull in all the school districts, and the data is just there in an easy way to use. But if that is indeed all of the questions, then I can rest my throat a little bit and drink some more tea. And I really appreciate all of you joining and listening to this incredibly wonky discussion about school district data and how to use EdBuilds resources for your research. So thank you very much. And as I said, we will share the recording of this session, and I will also share the slides that I used, which have links to all of the EdBuild project products that I shared. Yeah, thank you very much.